Hi, welcome back. In this video, we're going to look at how we can convert CSV files to S3 shapefile formats. So we're going to look at many different ways to convert CSV to shape using different tools, scripting tools, and also click-based softwares. So firstly, in order to do that, I'm going to go to this address, facebook.com/groups.qgis. So it's going to bring me to this Facebook social learning group, and then down here in the units I'm going to looking for Ipython Notebook. So it has so many things. So here is Jupyter Notebook. So I'm going to right click and open in a new tab and get back to here. If you cannot go to there, another way you can find that is you can click on here. So here is Jupyter Notebook, and here I got a template file, which is a Ipython, which is a Jupyter Notebook. So I'm just gonna click on download here, and I'm gonna download it to a location for this lesson, which is CSV to shapefile, and I save it here. So that is a template for the table contents that I'm gonna use. That one way you can download that Jupyter Notebook table contents template file. The other way you can type in here. If you are in the Qgis social learning Facebook group, you just type in here. You type in Jupyter Notebook template. So you're gonna see that here is just in here, and yeah, this one. Hopefully I click on that one. It's gonna bring me to somewhere. Anaconda notebook template. Or maybe this one. Yeah. So when you search that, it's gonna be the first result here, and you just click on download. Okay. So after I get that notebook, what I'm gonna do is because the folder that I'm working on, which is in this folder, so I'm gonna put it down there. Next, what I'm gonna do is to open Anaconda Jupyter Notebook, to open this notebook. So I'm gonna go to Start menu, and I'm gonna looking for Anaconda. Of course, you need to install Anaconda first. If you don't know how to install it, just go to youtube.com.c.qgis, and then you're gonna go to I think you can go to here. I'm not sure you can go to that. Let's try it within ignition mode. So if you do like that, yeah, I think so. You can go to here and you can search for Anaconda Jupyter. So I think install. So here you can find this video about install up and running Anaconda Jupyter Notebook and Spider for Python coding. So if you don't know how to, this is the first time you use Anaconda, you can go to there and follow this tutorial. But I'm assuming that you already have Anaconda in your computer. So we just start Anaconda now. So go back to Start menu, go to Anaconda tree, and you type in Anaconda prompt tree. So the next step I'm gonna do is I'm gonna change to the current working directory, which is this location here. I'm gonna change it to like that, and press enter, and I go D. So now it's in that current working directory. But I want it to be a bit more flexible, so I'm gonna call cd ... cd ... okay, to get back to that, and then I type in Jupyter Notebook. Okay, so it's gonna start Jupyter Notebook for me in here. So I'm gonna go to that location, and I'm gonna go to that. It's gonna be in CSV to shape. So that's the first setup that I did to prepare for that. So we can see that the new Jupyter Notebook template that we just download from Qgis social learning Facebook group is here. So what we're gonna do next, we're gonna just maybe make a duplicate of it, and then I'm gonna rename it to CSV to shape all in one, like that. So I'm gonna open it here. So here I can see that. So it's a table of contents template. It's very convenient to use. So what I'm gonna do here, I'm gonna type in the title here as converting CSV to shapefile. So the first thing here. So next we need to look for something to use and learn from, and I found on the internet. So if you go to this address, go to chris35wales.github.io CSV to shapefile OGR to OGR. So I'm going to copy this. It's going to bring you to this page. So this page is written by someone, I'm not sure who is that. is written by Chris Williams. So I think this is his blog based on GitHub blog. So written by Chris Williams. It's a geospatial analysis working at the British Geological Survey. So his post is, in fact, this is very useful. So we want to use this tutorial to follow and learn how to convert CSV to SHP shapefile. Of course, we have many more tutorials, many more reference, but this is the first reference that we're going to use. So what I'm going to do here is I'm going to say reference 1, and here is reference 2, and down here I'm going to have reference 3, reference 4, reference 5, and reference 6. Okay, so after that I can click on run. So it's going to make a table of content like this. So I can click on here, it's going to bring me down to the location of it, and I just change that as a reference 1. I'm going to change the content later, but for now just get it as a reference 1, and I can create a new cell here, put in it says markdown, what happened here, and put in the location with the reference. So this is the reference. Okay, so let's get started. So what we got here from the tutorial. So he mentioned that the ability to visualize CSV files within a GIS usually requires a couple of steps. If you are opening your GIS in a point and click fashion, this is fine for just a couple of files. But where we have multiple CSV files, it's going to take a lot of time. So conversion of CSV file, projected vector files, conversion of CSV file to vector files, and he mentioned that is a projected vector files. Here we're going to use SHP shapefile format. Can be done automatically using this library. So we're going to say that here's GDAL OGR to OGR. So we can change the reference first name here as using OGR to OGR, and maybe the name of the person as well, just to make credit that this is written by him. So maybe here Chris Williams from British Geological Survey. Cool. Okay, so first off, we need to make sure that we have GDAL in our machine. How can we have that? Okay, of course I have GDAL in my machine, but if you don't have GDAL in your machine, probably you can go to our YouTube channel called GIS, and you can search for GDAL. So in here, I think we have a Learn GDAL OGR playlist. Okay, so we have install GDAL OGR for learners and intros to vector data. As one of the resources we can also use as well. We got a fun reading. This is just fun reading one. You can also read, not watching the video just for fun, but you can follow the tutorial based on the original tutorial. We have a couple of so GDAL install. Maybe a good keyword to search for. So this is a good one. So another way to install up and running GDAL. So install GDAL, so that true video that you can use. If you don't have GDAL in your system, you can follow the tutorial and you can get GDAL in your system. But you know, it's gonna take a long time if we just get things set up and everything. We need to go straight to the point. But yeah, just as mentioned, we assume that we have GDAL in our system. So actually I have many versions of GDAL in my system. I'm not sure what GDAL version that Chris is gonna use. So let's say that, let's continue with his tutorial. Okay, so otherwise you can download a copy and install it here. He also have a link to that as well. That's good. But let's see what it is. So this is the from GDAL official website. So we can say that in the reference here, this is a tutorial. I just want to make that clear. This is by Chris Williams. And then here is GDAL installation. It's gonna be here. So how to do that? We can download here using different version, which is binary here. It's a good one. So we can install. So if we follow this tutorial, we can install GDAL here. So let's check that if we already have GDAL or not. Import GDAL. It seems that it's working. So I'm going to say help GDAL. What happened? We're gonna have here help on module GDAL, which is import gel.gdal as a convenient. Here all the function that I have in this GDAL version. This is a Python binding version, so a lot of functionality is limited. Okay. That for that, come back to Chris tutorial. So now we can get some data. So that is the tutorial. This is the GDAL installation, and next we need to have data. So the data location that we can use is from here, which is actually from his GitHub. So that's very cool. So then we download that. So in order to download that, of course, the first very easy way, just right click and choose save link as, and then we just save in here, and I'm gonna make it like reference 1. Yeah, to make it maybe R1, maybe data, just make it data R1. So it is data for the reference 1. That's clear. And the file name is sample. So make the file name is sample here and click save. So we got that. We check in the folder here, data sample. We got that. We can also using bash command to check it if we want. We can call bash. We can call ls and maybe data reference 1. And we see that we list data reference 1 and we have the sample xy.csv inside there. So it's good for now. So if we open that, we're gonna have the file looks like this. So let's say we're gonna try to use bash command to open it. You can have cat data.that and the sample file, and then we run it. So this is the way that we can open using cat. It's gonna look like that, the whole file. If we want to look just a head of the file, we can do as well, head and then data and sample. So we have the 10 first element, and we can also see the tail of that as well. Just copy to make it quick, and then we have also 10 last rows of data in the file. So this is the data in the file. We got that, and if we compare with what he say in his tutorial, okay, it's correct now. So we are ready to go to the next part now. So let's say this part probably I'm gonna bring up there. I'm gonna make it as preparation. So here one note on download data. So actually one of the way that we can use is right click and choose save link as, but from the Jupyter Notebook we can also download data using script as well if we have the location like that. So let's say just to say the first way, that is method 1 is using bash command, using shell command to download it. So we get back here and we come back to the note on download data. So we got this location. So the first way we can do is we can using bash shell command to download it. So in bash shell command, we have a function called wget. We can download it there. So what I'm gonna do is I'm gonna do wget and .health. So this is a function. It's gonna the version, the health background. So input file, output file. Okay, input file. Okay, so this is, so that means we will specify an input file for the download, then we're gonna specify an output for the file. So that is a health. Let's try it now. Here, down here, using bash command wget. So the input, let's say input file as instructed here. We're gonna make it a little bit bigger. Okay, here. So we just put in the location of the file from Chris GitHub repository. Then we put in the output file here, -o, and I'm going to put inside here. That is the output. And let's say using wget like that. So we're going to run it. So I'm going to zoom in to see the script. So here, I'm going to run it to see how the download is going to work with wget. It's running now. Hopefully it's working. It's not responding at the moment. Some reason it's not working. Maybe the thing I put in here is confusing. So let's check in the folder. Okay, so it's already downloaded the file. And if we open it using Notepad++, we're going to see the content of the file here. Okay, will not apply here. This is not what we are looking for. No, this is not what we are looking for. So something wrong here. Something wrong there. So the script is not working that way. Okay, we get an error. That's okay. So what we want to do now, probably we're going to change this to just make it not necessary like that. No input and no output. And make it in the double quotes like that. I'm not sure it's working. Just run it again. Okay, that's interesting. It's not working that way. What if I'm gonna use that. I'm gonna just save it in here, and then I'm gonna just using bash command to list everything. I got the sample in this folder. I'm going to do this again and run this again. I got many sample files. So I'm going to read the content of that sample file. It's working. So CSV1.1 is working. .2. Okay. So that's the way that we can download it using this way. But it's sadly that it's not working that way, especially when we cap that that you get, and the content is not what we expected. Okay, but that is the first way that we can download the file from internet using shell command. That's convenient actually. So after we download it, we can make a move using bash command. So after we download it, it's gonna get into the current directory. So if we want to, we can move the file using bash command to the new location, which is data and sample, and we override that one. So we run that, and then now we can cat or head that file. So we just head and paste it in, and it's working now. So that is the first way that we can download the file using shell. So next time, whenever we have a address like this, we just go wget to download the file. The method 2 we can use to download the file is using Python. Okay. So actually I have a template here I already used for my other work. So I'm just gonna copy it over. Okay, yeah. So what I'm gonna do is I'm gonna put in the URL here. So in this script, I'm gonna import the request module. So firstly, if when you did not install request, you need to install request now. Then import OS and import group. Then I need to define a function called download URL. Put in the URL, put in the path that I want to save, and the chunk size, which is I think to make sure that everything is not saved in a memory, and it's a chunk size to reduce saving in memory. And if your memory is not large enough, your RAM is not large enough, your computer is not fail. So I'm gonna copy the link. I'm gonna run this again. I'm gonna copy the link up there, and I put it in a function there. So what is the output that I want to download to? The save path is gonna be in the data. I can Qgis path. Okay, what happened? Join, and then I put in data, and then I put in this file. It looks complicated, but actually it's the same as this one. This is the same as this. Save path is equal to just data R1 that, and you plot the name of the file. It's exactly like that. But with this script, it can help you to get the name of the file automatically, and it's saved in its location. And maybe I want to make that name is a bit more specific. Oh, what happened? A bit more specific. I'm gonna copy this and comment it out. So it's gonna be sample hy, and it's gonna be y.csv to make sure that the download is using Python. Then I can run it now. I can list this after I run it using that one, which is the save path, which is CSV. So just download it first. It's working very quick actually. So now I can use OS to change working directory to data. Then I can use OS to list directory. So you can see that we got a file named that one. Okay, and we can also use Python to read the content of that file. Let's say in file is open sample hy file. I'm going to make it as read only. In file close. Then for line in file. So firstly I'm going to print out. I'm going to print out the length of the file of in file. So it's going to bring me the length of that file. I know how many lines of data inside that file. Then I'm gonna print out the first 10 lines. So I'm gonna put in the index here and the line, enumerate that one, and if index is less than equal 10, I'm gonna print the line. Something wrong there. It's low length. That says low length. That's alright. That's interesting. That's not working. That's alright. I'm gonna do it later. So this is what happened. line.strip dot put out that, and line, that's the content of the file. It's different from empty. That's interesting. Strip is not working. I'm gonna do line dot replace, and I want to change new line by empty. It's the same. Look at that. So this is a very short script that you can read the content of the first 10 line of the file. So we got it's the same here as his instruction. So that's good. So that's the second way that you can download the file using Python. So this is very flexible. You can use wget to download the file, and you can also use Python to download the file. So that's enough for the preparation. It takes too long for now. Okay, so the next part we're gonna do, so this is preparation. Next part we're gonna do is get into the content. So from his tutorial, we can see that the next step we create a Dbf file. That's interesting. Create a Dbf file, and then next create a VRT file, and then create the shape file. That's so interesting. Create a shape file. Then we can open in a GIS, and more OGR have. Take a look there. What is this? This is Boston Geographic Information System. That's so good. This is an OGR to OGR cheat sheet. From that, so many good functions here. That's so cool. Even have a book called Qgis in Action as well, which is a MIP one in Manning. This is free previous edition included. Look at the MIP one. It's a new edition, which is now just $25 US. This is a good one to buy. That's something, a spatial database, spatial reference system, booking wheel data, Qgis with a desktop, raster function, cool, raster, copy, terminology, raster constructing. Wow, that's interesting. Qgis using SQL. Okay, sorry, I was distracted by that one. So get back to there, our content. I'm going to run this and get to preparation finish. Okay, so top, create a Dbf file. So here is create a Dbf file based on his tutorial. So working with the command line where GDAL is available, this is the way that we can do that. In the same directory as you have the sample XYZ file, we're going to do this. So firstly, we need to know what is our current working directory is. The first way we can use is using Python, and the second way we can use is using bash command. Interesting. This is pwd. It's going to be the same as you see that. In Python, it's going to show you the same as you see in Windows Drive path system. But if you use bash command, it's going to show you MNT here. For the beginning, it stands for mouse point or something like that. But it's interesting to recognize. So how to create that GDAL Dbf file? Very simple. We're going to use this in the shell command. So from the Jupyter Notebook here, you can just type in bash like that. And you're gonna type in OGR to OGR and put in F, which is format, and you can put in this one needs to be very exact, because this is the format name provided by OGR to OGR function, OGR publisher module. Then we need to put the output file here as sample xy.dbf. Then we're going to put in sample xy is the input one. So this is the input, this is the output. Interesting that we don't need to put in the input and output. It automatically understands that this is input, this is output, and we run that. And it just converts this to this file. And by the way, if we want to get help from this file, we can do bash command. It's working actually now. Let's to see that. Okay, so we got a Dbf file now. So this command is working from Jupyter Notebook. So how it's interesting is that normally you have to use the command line, but you can call the bash command line here from Jupyter Notebook. And what I'm going to do, I just forget, I just lost myself. Okay, so if we don't know how to use OGR to OGR, we just put in help like that. So we can see a bunch of things like that. So here we can see that, let's say help general. Okay, that's interesting. So it's not very clear actually. If you want to get help for OGR, you need to go to website. But we can see here is -f, which is format name. Okay, so here in the function we choose -f, which is the format name, and then we're gonna have some input output somewhere. We need an example. So if you want to look for example, we just go to the website. But just this is the way that quickly we can see that. Okay, I'm lazy, not reading anymore. So we're done creating Dbf file successfully based on quiz instruction. The next step, we need to notice that this is the destination file, okay, and sample xy is the input file, okay. So after run that, we check if it exists. Yeah, we check it, it exists. The Dbf file will be used in the next step to create an actual shapefile, okay. So if we're gonna go to the folder, we're gonna right click on here and choose open with notepad, and we can see that here this is the Dbf file is open using notepad. It looks like this. So actually it's gonna bring the content in here. So this is Dbf file. The next step we're gonna do is we're gonna create a virtual file. So what he written here, before we can create our shapefile, we must create a VRT, which is virtual file, which describes the shapefile geometry type, projection, and source data. So this may seem cumbersome. Actually, it's cumbersome to me from the beginning, but can be automatically eventually to so stick with it. Automated eventually, so stick with it. Okay, thanks. So in the same directory as we have that file, okay, now we have in the same folder and this folder together. You're going to use a text editor. Wow, create a new file called this one. Inside, type the following one. So instead of using a text editor, I'm going to use Python. Okay, or I'm going to use Python is good. So I'm gonna out file. Let's open a file called, what's the name of the file? So the layer is going to be called sample xy. We have specified the data is coming from. I'm looking for the name of the file. Okay, here's the name of the file. So I'm going to put in here that way, and I'm going to put in right, and our file dot close like that. So it's gonna write a file. We're gonna open a file. So you're gonna check in the folder. We got a new file. This is a text file .vrt. Okay, we're done for that. Now we need to put in some content for this file. So we just our file dot write and put in here like that. Boom. And then we copy from Chris web tutorial here. Put everything in here. So what is in here? Hopefully he's gonna help us to explain here. So the layer will be called sample xy. So here's the layer name is sample xy. Okay. We have specified where the data is coming from between source data tags as being sample xy.csv. So this is the name of the layer. This is the data source. We have two tags to this one, and then in between we put in this. This is data source. Okay. After that, we specify the geometry to be a point type using WKB point. So here we got WKB point, and then the tags is geometry type, and we choose it geometry point because this is CSV to shapefile point. So that's cool. Then have set the projection using project for string. You can use EPSG codes too if you prefer. Okay. So just to make sure that it matches the projection of the points in the CSV file. We don't know the projection of the point is, so just use Chris projection because this is his data. We don't know his projection, but this is the projection. This is the WDS84. Okay, so this is projection for string between layer SRS, which is system reference system. Is that SRS stand for what? System reference system, or maybe CRS is make more sense, but that's alright. This is the layer coordinate reference system. So this is the whole inside here. The whole inside here is project for string. It's not very neat to be honest, but yeah, it is the way it is. And the next one is, and finally notice that we have set XY columns headers under geometry field encoding to X and Y. So here we got geometry field encoding, okay, and this is point form columns, x is equal x, y is equal y. This is a way that you're going to get the data from sample xy, get the column name is x and y. So that means the CSV file is going to have kind of column x and y there. Hopefully, let's have a look. Here is a it's a file I'm going to open with Notepad++. Yeah, exactly. This CSV file have a the first line, which is the name of the data column, x and y. So that makes sense now. Cool. Close this. And that's it. So that's the content of the virtual file. So this is the way that we can create it. I'm going to run this Python script. So what it does is create a new file, write the content for the file, and then you remember to close the file. So now we can use Python as well, which is in file. This is open dot sample virtual file, and then in file dot close, just to make sure that, and let's say print inside the length of in file. It's not going to work that way. That's alright. So for line in file, we just print out the line. So you want to see the content of the file. Okay, it looks like this. So interesting. Before printing it out, we need to line is equal line dot strip. Okay, so it's going to strip out the new line. It's going to look like that. So this is content that we want to have the file. Using Python, we can write out the file and we can read the content of the file. Another way that you can read the content of the file, which is using bash command, which is cat and sample. It's going to work the same for me, for us here. So we done for the VRT file, but I need to put it up there. Okay. So if we go to the folder, we open the VRT file using Notepad++, we can see the content look like this. But that's interesting that the first line is empty. It needs to be not empty. So we're gonna check the codes again. Okay, because the first line we have something there. Why is it empty? We just write the content. So if the content of the file is empty like that, it may make a problem. Okay, we will check it later. So we finished creating the VRT file. Okay, so the next step we're gonna do is we're gonna create the shapefile. Here, create the shapefile. Okay. So in our sample xy VRT file, the virtual file, we can now create the shapefile using OGR to OGR as follows. So here the information that we can create. So we're gonna need the command line. So here in bash command, we can type in OGR to OGR. F is the in, S3 shapefile, and the input and the output is sample xy, and the input is sample. The input is virtual file. Input is not the xy, that not the CSV file or not the Dbf file, which is virtual file. That's interesting. And then we run it. So we got a warning. Cannot open. For some reason we cannot open that file. Maybe it's opened by something else. So we're gonna do it again here. We're gonna run this file again. Okay, and the file is closed already. Again, one more time. We do it again. Why we got the warning? Had no idea. Maybe because of the space from the beginning of the file. So let's delete the space. Then run this again. So it's working. So we can put a note here. It's very special note here. Do not keep empty line in the virtual file. It's not gonna work. So after we got that, check from the instruction here. We check the folder, we're gonna got a new directory. That's interesting. So this will put all the files associated with the shapefile into a new directory called sample xy. Wow, interesting. Note that the last argument about sample xy.vrt here is the input data. Yeah, we mentioned that. We can change the output location if we want to. If we don't change the output location, this is actually not the output file, this is the output folder. So if you want to change the output location, just put the change the output folder name over here. That's so cool. So if we go to the sample directory here, we're gonna see 4 files, which is dbf, which is copied from outside, projection, which is the projection information defined by the virtual file, the shapefile, and sample xy. Sample xx, I think this one is like geometry definition. Cool. So we're done creating that. So here you can see that we got a problem with this creating this file. So what I'm gonna do, I think what I'm gonna do is I don't know, writing a line that let's say write lines. It's working. Look like that. The cat. It's always have the first line empty. Reload it. How is it working? No, it's not working. The first line is still empty. Hey, we need to make something here. We're gonna put it like this, and it's gonna be like that, and put it out. Then we check again. Now it's better. Okay, so that is the way that we can create the new file, new virtual file, without making it empty. That's so cool. The reason why I wanna create a script using the reason why I wanna create the visual file using script, I'm gonna explain in the next part of this video. So that's it for now. Create a virtual file, and we done that. So we done create the shapefile, and it's working perfectly for us now. And with that file, we can open using Qgis. So I got the Qgis open here. So what I'm gonna do is just gonna put the shapefile in, and it's gonna look like this. And if I open the table of content, I'm gonna have all the XY value. And if I check the coordinate system, I'm gonna have that coordinate system. I don't have the coordinate system. Encoding point, unknown coordinate system. Sad. But this is here, WGF34 or something, coordinate system. Okay. And if I want to compare with the result that he showed us here, is actually the same in Qgis. So that's fantastic. So now I'm gonna explain a bit more about why I was trying to use Python script to create the virtual file. Down here, I'm gonna say how to make a virtual file, VRT creation. Why I care about that? So for example, here is a file that I want to create. Okay, and because this is Python script, so I'm gonna have like a bunch of customization that I can use in this Python script. So because we have here, we have the OGR virtual file data source here. It's inside that visual layer name. So the layer name is that one. So we're gonna make the layer name here as OGR layer name. Okay. Is that one. So how to make it something like that? We're gonna I don't think we need right line here. Yeah, I don't think we need right line there. Just right and check it. It's working. Check it. Yep, it's working fine. So I'm gonna use right instead of right lines. Okay, this is the same. But what I want to say here is OGR layer, the first one, and I want to make this as a variable. So it's gonna be something like this. Okay. The next thing I want to do is that the source data. The source data here is this one. So I'm going to make that. Oh, sorry. As this one. Okay. And need to be like that. Need to be like that. I'm not sure. I'm going to print. I'm going to run that. This one needs to be in double quote. I'm going to print now this one. How it look like that. What I expected. I'm going to print now this one. Look like that. What I expected. That's great. Then the SRC layer is gonna be sample XYZ that, which is a folder, I think so. No, not really. And so it's in a single code. And when I print this out, it's gonna look like this. Didn't run it. Look like that. Of course, we need to put it in here and just get that. And what else? I'm gonna join the geometry type. This one is gonna be the same. It's gonna be like that. And the layer as well. Okay, gonna define that as something like that, and just put in a layer in there. It's gonna look like that. Then next one is this one. This one is a little bit tricky. Geometry field should be okay. Encoding should be okay. Encoding is equal to this one needs to be defined as something like geometry field encoding. Then I'm gonna put in the whole of this one here. This is very tricky. I'm gonna put in like that, and then what I got, that's wrong. That's not working that way. 1, 2, 3. I'm gonna put that one. 1, 2, 3. That's working, but I can use one only actually. So that's what I get. It's exactly point from column double quote x is equal x, y equal y. That's it, and that's it. That's done. Okay. So instead of writing everything in a file here, I'm gonna make a something called F format, and inside here I can put in OGR layer. So everything here is gonna be in a curly bracket like that. I'm gonna put in that one. Okay, so for testing for now, maybe I don't need to test it. I just I'm gonna copy the code here, and I'm gonna just quickly print it out. Yeah, so it's working. It seems working. Yeah, that one is this one perfectly. Just put the F from the beginning there. So the next part, I'm gonna put in the sample file there. So just put in this to change the name using using the variable. Why I need to use this? Because later, when I have different file name, I can automate it. I can put it in a loop. So it's like a dictionary or something like that, or a list of the list. So I can define that. And then I can automate to generate like multiple CSV file to a shapefile, multiple CSV file to shapefile. It's going to be amazing. And then SCR layer, I'm going to put it in here. So the same is going to be inside a curly bracket like that. And it's working actually. This one is the same. The geometry type, we're going to put in, okay, going to put inside here. Run that. The layer type is very long there. Make it simpler by putting the curly bracket there. Put it inside. It's working. And even I can, okay, I'm not sure that the GDAL OGR is going to work in here. So do we have GDAL? I'm going to help GDAL here. Does this have the OGR to OGR function? I'm not sure because a lot of function here is not working. So I'm going to help OSGL. We didn't even import OSGL. Okay, so we got OGR. Okay, so OGR.OGR. Okay, so here's OGR in OSGL. I'm just thinking of using a Python binding instead of the command line. So you can make it everything is Python. So in just a single run, we can convert the CSV file to shapefile in one single click or one single script. It's easier than preparing step by step. Of course, we already have based on the Chris William instruction, we already have that. We just want to tailor to fit our need. It's not different, it's not new, it's just our need. It's very long. I'm going to make it like that. It's going to be better to read because, oh no, not good. Actually, it's one longer. Layer, so long and detail. That's good. As more detail is good, but it's kind of long time to search for. Maybe we can, sorry, put me away. Okay, the function can search for OGR, not that one. Okay, in here, in the side package. Instead of doing that, I'm going to go to the side package here. I'm going to open it using Notepad. I'm going to open it. Why it's not valid? And this is a file. But the health is somewhere. OGR to OGR. OGR to OGR. So I'm going to define OGR to no function called that. I'm going to shapefile. That's not working. I'm going to get back to there. Not very happy with that. Trying to find a function, but I can't. This is a file. OGR to. No, can't find it. So it seems that we can easily we can easily create our own Python binder instead of using the binder provided by OSGR. Okay, so the next part of the video, I'm gonna create that. I'm gonna create a Python binding, our Python binding version from the EAC standard installation of GDAL in my computer. Instead of using this is not working. It's confusing, it's not working. Okay, I give up for this one. So okay, make it simple now for now. Okay, so I got that, and I also need to put in the geometry field coding as well. Same that. Okay, that is the geometry field coding. And even here, if the code is something, you can even choose a format like that. Is that working? It's still okay. That's fantastic. And then I will choose the axis. It's actually X, and the Y is actually Y. I'm gonna put like that. Yeah, you need to be. Don't need to be. So I'm gonna put it inside there. So I'm gonna make it one run. Everything gonna work from like that. And if I can create the Python binding, I can even create it using Python directly. Okay. So the next part, I'm gonna create the Python binding. But for now, that is the first step to create the VRT. I think the most complicated part of this creating, converting from CSV to shapefile is generating virtual file. And we are trying to do what we are trying to do here is we're trying to automate that task using Python script. We're done for that, and we check that we don't do that. So we got the file, we got the content there. Now we can copy this one and create the shapefile again. And now we can remove this. Of course, we can need to run this again here. And maybe to make sure it's working. It's not really working. Look at that. Firstly, create that one, and then create that. Take a while, but it's not working. Okay, so the file has problem. You check the file. What is the difference between the two files? So what I'm gonna do is I'm gonna make it two different files. So from here, we're gonna go it as the original one, and then we run that, and we run that to make sure it's working, and then we run this, and this is working for us. Actually, it's working. So now we delete that folder. But sadly, that is sample. That's wrong. It should be sample. Why is sample? Because I put in here is sample. It's interesting. And here, what I make is sample. Cool. No, that's interesting. It's a virtual file that we create. It's not called sample. So in the folder here, sorry, a lot of confusing here. Delete the virtual file, delete the Java database, delete the virtual file, and we can also delete everything. Okay, so what I'm gonna trying to do is even download everything here as well. Make everything in one script. Make it here. So we have the first part is download the file using Python. It's gonna be in there. But because we are in that location already, so it should be just that file. We can comment ourselves, save as. It's just sample CSV. Make it simple, less confusing. That one. So we're done for the first part. We can test it by going down there and check the folder here. Okay, we got the sample. That's working. That's great. The second part is we can we create the sample. This sample is not that's not good. We need to make a sample file. It's a typo mistake. Dangerous. Working now. Okay. So everything in here from the beginning. That one is so this is step one. Step one here is downloading the Python file. Step 2 here is create the database. Did we create the database file? We did not, so we need to create the DB file. Oh, okay, we still need that one to create the DB file. Not yet automated actually. So step 1 here and step 2 need to create a Python binding using sub process. Okay, the first step, download the file. The second step, create a DB file. It's working here. The next step, create this is step 3, create virtual file. It's working there. And step 4, which is we create the shapefile. So now we're gonna get that, and we're gonna just open with something, put the Qgis there, put in, it's working for us. That's fantastic. That's Shapefile. Okay, so this part is done, which is automate the virtual file creation. This is what we done. We instead of making a text file manually, we use the F format Python method, and we can put in some variable. So later on, we can change this value. That's very convenient. Later we can do. The next step we need to do is we need to create some Python binding in Windows using subprocess to call the OGR function to run this instead of running this using bash command or command line in Windows. We're gonna use this. We're gonna run this using Python. So that's for the next step. The step gonna be create Python binding using subprocess for OGR to OGR functions. It's gonna be useful later. Okay, so in this part, we're gonna try to create some Python binding function using subprocess to call OGR to OGR functions in Windows. Looking back from the previous step, we got the step 1 is downloading the file using Python here. We download the file. Step 2, we got it. We create the Dbf file using Python, using OGR to OGR function. Actually, this one can be done using Python as well. So I'm gonna give it a try to search for Python to create a sample as a Dbf file for shape creation. Let's see how it works. So that's interesting. It has a module called PyShape. You can use this as well. Wow. So this is a Python shapefile library. You can read and write shapefile in pure Python. That's insane. Reading shapefile, writing shapefile here. Do we have any version? Any example reading shapefile here? Reading geometry. We want to write shapefile, writing shapefile. Okay, we write the Dbf content manager, but we need to make a CSV. Okay, I'm gonna look at this later. Don't be distracted. Sorry. Pandas shapefile primer. PyStack for climate. I'm not gonna create say the shapefile. Just that one. Dbf. Okay. Yeah. So creating DBFs in Python. I currently have a Python script that I'm in the middle of the video. Okay, I'll put SHP. This is ArcGIS. I want a poor Python solution. So import DBF. Okay. I'm looking for the answer. Okay. So we're gonna have the library called Dbf function. So Python Dbf creation example. Okay, that's interesting. This is minus view command. It's gonna show us this one. We want the Python data Dbf. Okay. Wow. Okay, so to understand that we can read the Dbf. This one. It's a whole module. Dbf module can help to write Dbf file in Python. If we want to have a look on that. Okay, later. Want to make something simple for now. Okay, so the first step is creating Dbf using this. This is a command. Okay, so I'm gonna open the folder, and in this somehow when I create I still putting this one. That's funny. Yeah, delete that. So here we got the Dbf file inside that. I'm gonna make a command line. and I'm going to put in OGR to OGR. So it's working for me, so that's great. So instead of using OGR to OGR, I'm going to put in OGR to OGR F format, which is SV shapefile. And the input is just CSV, I think. I need to make the Dbf first. So this is the way that I can make that one, which is Dbf first, and then the CSV. But before running that, I need to delete this Dbf file, and I run this in GDAL window. And you can see that it's working fine for me. I can open it using Notepad, and this is what it is, exactly what it is. And then after having the Dbf file, this step, I'm going to run this using the virtual file, and I'm going to run this. And I can check the shapefile is created using Qgis. It's working. So that, just to make sure that GDAL OGR to OGR function in Windows is working for me. So the next step is I'm going to need to use sub-process to create a Python binding. So what I'm going to do is I'm going to copy the whole step here. I'm going to copy, I'm going to paste this here. So just make it step by step easy for me. The first step, the second step here. So in order to, I'm going to code Python sub-process. So this is the documentation for sub-process. So what we need to looking for some. So we're looking for an example. Probably not very good. So that is a sub-process. I'm going to go to facebook.com.c.groups.qgis. I'm going to go to probably here, go to file. I'm going to go to file, maybe. I'm looking for the file. Not here. I'm going to make it larger. Some file here. Okay. So in here, I'm going to download this pyvideo.library. Okay, so I don't need to download it, I just open it online here. So I'm going to go to because in this is a Python library file that I use for our Python video processing series. So in here we actually use sub-process to create some Python binding function to call YouTube DL and also FMPEG to process video. For example, this one. So I'm going to copy this and I'm going to put it back in here. I'm going to put it here. Okay. So what we need to do is we need to create a Python binding function for this one here. So firstly, we name the function. Here we're going to call it OGR to OGR, which is create Dbf py. It's a bit long, but it's recognizable, and the input file and the output file. So here we got the input file and the output file. Okay, so here we're gonna make it OGR to OGR file, and the location is gonna be in somewhere in C drive, in program file, in GDAL, in OGR to OGR. Yeah, that's one. We're gonna put it OGR to OGR. Copy that one. And we're going to put in here, and we're going to change the path to be forward slash instead of backward slash, and then we run it. We're going to say running OGR to OGR, and we're going to put that file in, and then we put the input and the output. Cool. Then we call the sub-process. Of course we need to import sub-process, and we call this file, and here we just put in something like this. So we're going to put in F here, and then we're going to put in this one, and the in file. This is the out file, so the out file first and the in file later, and it's called SV here. So then that, and then it's in file here. Because we got we call the command, we get the F function here, I make it zoom better here, and then put in SV shapefile, and then we put in probably gonna put it in like this, so to make it exactly the same like this one, and then the out file and the in file, and then we can print out done with that one. That define a function, so now we can test it using this, and the in file here just gonna be sample CSV, and the out file here just gonna be sample Dbf. Okay, that's it. And we check the folder. So we're gonna delete this, and we want to delete the Dbf as well. So now I'll put in a side here. So I'm gonna run it now. It's not working. Why? Because the name sub-process is not defined. So of course we need to import sub-process. So maybe we just import the sub-process inside the function here. We run again. Inconsistent of tab and space in indentation for this one. Okay, so we got this one is import. We need to change this one to that one and run again. So it's working now, and let's see if it's working. It's actually working, but where is the out file? We're running the input and done with the output, but we don't know where this output. So we're gonna choose os.path.full path. So os.path. Absolute path. to that one, put the out file, we'll run this again. So now we got that the absolute path of the output is in here. So it seems that the function is working fine, but it didn't create the output that we expected. Okay, so let's try to make it separately here and then make it here. It's running, the input file is XYZ sample, the output file is that one, but it's not working. So let's say put in this one is like that. Okay, so that's done. Cool. So it's working now. We got the Dbf file now. We open quick notepad. It's exactly what we want to. So now we're done. We've done the step that create Dbf file using Python binding. So now whenever we need, we just call this function, and then we can create the Dbf file instead of go to command line or go to bash command. That's very convenient. We can put this one into command here. Delete this and delete this. So that is for the step 2. Then we go to the step 4, which is create shapefile. It's very similar. We're going to copy that function and we're going to make a new shell here. Going to copy this one and put this in here as a reference. And then the first thing we're going to do is going to make create shape. Change the name of the function. Create SVF like that. Infile and out file. So for now it's not infile and out file. It's going to be infile and out folder. Okay. So infile now is a virtual file. So it's going to be this one. And out folder now it's gonna be this folder. Okay, then we put in infile and out file. Is that the function is the same, it's just a little bit different. F as we shapefile is gonna be out folder, and the final is in file, and we print out the out folder and we run it. What happened here is the out file is not defined somehow in here, so it's working. We can check in the sample folder here. You can put it aside here, and we check in Qgis. Put it in Qgis. We got the shapefile, so we done the Python binding for all the OGR command now. So we done it now, and we can delete this. So now we have everything, which is include step 1, step 2, step 3, step 4, and step 4. So now we want to put it all together. Put it all together to create shapefile from CSV. So we're gonna copy it. Here's the first step, is copy it, download using Python. Download the data file from the internet using Python. The second step we're gonna use here, you're gonna copy this and paste it in here. I guess neater, which is create Python function to convert, which is Python function to convert to create a Dbf file using OGR to OGR. Step 3 is create a file using Python. So we're going to copy this step 2 here into the script. Step 3, which is create VRT file using Python. So here is just checking the result of that. I'm going to put it down there. Okay. And then step 4, create the shapefile. So we just copy it. So before running that, we're going to get to that folder. We're going to delete everything. Okay, we need to remove this one from Qgis and then delete this folder again. So the folder is empty now. We're going to run this script. This script is going to download the file from this location provided by Chris William based on his tutorial. And then we're gonna do something like we're gonna create a Python function to create a Dbf file using OGR to OGR, and then we create a VRT file, and then we create the shapefile, and then we run it. Very exciting that the shapefile is created in this location. So we're gonna go to that location, and we see that it's download the CSV file, it's create the Dbf file, it's generate the VRT file, and also generate a folder. And inside this folder is a shapefile. And if we grab this, put in Qgis, we get the shapefile that we want. So that's it. It's put all together the script to convert from a CSV file to a shapefile using Python from beginning to the end. Everything is in Python, including downloading data. So from the previous part, we put all together to create a shapefile from CSV. In this part, we're going to add one more part, which is after we create the shapefile, we're going to view that shapefile using GeoPandas. So we run it here, and we got that here. So to demonstrate this again, we're going to go to the file, we're going to delete everything. So in here, we're going to have different part of the script. So the first part of the script is going to be download the file. The second part of the script is going to be create Dbf file. Then we're going to convert it, we're going to create a VRT file using this script. Then we're going to, this is actually just creating, checking the VRT file. Then we're going to create a shapefile using script, and then we import GDAL pandas as GPD. Then we define the shapefile location. Then we're gonna make a GDAL pandas GDAL database. Then we plot the map out. So I'm gonna do that. I'm gonna run this again. You see that you're going to download the file here, create a Dbf file, create a VRT file, and also plot the shapefile using GDAL pandas. So to check that, we're gonna go to this folder. We're gonna open Qgis. So we just grab and put in Qgis, and it is exactly what we got. And we go to the tutorial provided by Chris William. This is exactly what we got. Okay, so that is we done for all-in-one script, downloading, creating shapefile, and viewing shapefile as well. So actually we can be finished with this video already, but I'm just thinking that not all the time we use Jupyter Notebook. So I'm thinking of writing a Python script separately from this notebook, so we can run it from different Python editor, or maybe directly from command line. So here, what I'm going to do is I'm going to delete everything here, and I'm going to go to create a new Python script out file using open, which is called maybe CSV to shape all-in-one .py. Then I'm going to write it, and after that I'm not forgetting to close this file. Okay, so basically I'm going to create a new file here. It's empty now, so I'm going to write something into the file. Right, what I'm going to write in, I'm going to put in R triple quote, and put in here, and then I'm going to copy the whole script from the previous section, and I'm going to put inside in the middle of triple quote here and paste. So I got everything inside that. Why I put the R here? Because this R is going to make everything inside here is the same. But if I don't put R in, this one, like the new line, is going to make the script to be a new line here. So it's wrong. I want to keep everything inside here to be a script. So I'm going to run that, and I check the content, and I got a new Python script there. Okay, new Python script. So with this new Python script, I can open Spider. Firstly, I need to change the current working directory to this location by doing that, or just check the current working directory. And then now I just open the script, and now the script is inside Spider. Now I'm going to run it step by step, so I'm going to make it a bit larger to see. So the first step I'm going to run is actually step 1, downloading the CSV file. I'm going to just go to run F9, and you see on the left here a new CSV file is downloaded. Next step I'm going to do is create the Dbf file. New Dbf file is created. Next step is create the VRT file, and VRT file is created. I'm going to just read in that file to see how it looks like, exactly what I want. Next, I'm going to create the shapefile. So the shapefile is created at this location, which is here on the left. And with shapefile, I can open using Qgis. Yeah, so it's good to show that in Qgis. I want to put it aside here. On the left here is Qgis. Okay. And the final step is I can plot the shapefile using GDAL pandas inside Spider as well. So I'm going to choose that and that. So we have that here. We can change the shape a little bit bigger to maybe 20, and then run this again. Is that not the one? Figure size. Okay, so we see that this looks like that when we plot it out in here. But maybe 15 is better. Look like that. And actually pretty nice here. So that is running the script outside using Spider. So when we have the script, we can actually run from many different environments, even running using Notepad as well. So we close the script here in Spider. We're gonna open the script using Notepad++, and I'm gonna comment this out because I don't want to run the plot path. I just want to create everything. So I'm gonna delete the CSV, Dbf, and VRT file. Delete the shapefile here. So I'm gonna save this and go to macro, choose run Python 3, Python.org. I'm gonna run that. After running that, I'm gonna have new CSV file, new Dbf file, new VRT file, and the shapefile. And with this shapefile, I'm gonna grab it, put in Qgis, and get that. So that's a new Python script that I generate using Python as well. So it's interesting that using Python to write a Python script And we can even using that Python script from here. We can in Jupyter Notebook. So firstly, we can read it in to check how it looks like. We can do like that, and we can put in the name of the script, which is .py here, and we just print it out. So this is exactly what the script look like. And then we can even run the script using run in Jupyter Notebook here with the script name. And we run that. So let's say we delete this, you're gonna edit the script to make sure the reason why we didn't see the plot of the gel pandas part here because we commented this already. So we need to generate the script again and then open this again to check it. So it's all good for the path, and then we run the script from here in Jupyter Notebook. So we see that new shapefile is generated on the left here, and the shapefile is looking like this in Jupyter Notebook. So that's it for this part, is generate a new Python script, and this concludes this pretty long video about converting CSV to shapefile. I hope that you like it, and thanks for watching. Subscribe, smash the like button, and see you later for the next video.